What's up, everybody? It's Mr. Ellis, your algebra teacher. I'm going to be making the video for week 5 assignments today. So let's just get started. As always, I'm logged in as a student into the course. And so we start off on the 20th for week 5. So let's go to that assignment. I believe it's a Marquez reading. And as usual, I'll let you do the Marquez reading on your own, 3 to 5 sentence summary. But questions, what does a linear function look like? Okay, and so how would you answer that question, right? So you're going to go to the slides, right? Because I got a picture of linear function. Actually, I got slide 2 right here. Function that is simply a straight line. Okay, so what would it look like? Maybe it would look like, and this is a picture. So what does that picture look like? All right, and identify the parent function of the graph on the last slide of the Google Slides. Okay, so let's go to the bottom. Okay, what's that guy? Maybe we scroll up a little bit, we can find a slide about it. Let's picture that. Ooh, quadratic function. Graph should look like a parabola. And x squared right here, because it says right here, not of x to any power higher than 2. The function, that is x squared, that's what it means. And yeah, that looks like a parabola to me. Okay, so that's it for the 20th, right? So let's move on to the 21st. Parent functions. Okay, it says answer all questions in the document attached. All right, fun. Full workload, right? Okay, first one, identify the parent function of the graph below. Again, so we're thinking linear, quadratic, or exponential, right? So what does that look like? Does it look like that? Because then it'd be quadratic, right? Does it look like that? Because then it'd be exponential. Or does it look like this? And then it'd be linear, right? So it's got to be one of those three. I guarantee you that it's one of those three, right? So parent function of the graph shown below. Okay, what does that look like? Does it look like this guy? Then it'd be a linear function. This guy, it's going to be quadratic, or this guy, it's going to be exponential. It's got to be one of those three guys. So, and then identify the parent function of the graph shown below. What does that one look like? Does it look like this guy? Does it look like this guy? Because the first one was exponential, this one's quadratic, and this one is your linear, right? So which one does it look like, guys? And we just got 3 more problems. Ooh, given the table below, identify the parent function. Well, what the heck? Now we just got points. How am I going to find the parent function now? I can't see what it looks like. Well, maybe I can, right? What if I graph it? I'm going to go to desmos.com, start graphing, and I'm just going to graph the points, guys, row by row. So I see I got a 0, 6 in this row, x is 0, y 6. So what do I go to Desmos and do? Parentheses, right? 0, comma, 6. Like that. And look, it gives me a nice little dot where the point will be on my graph, right? So what's next? 2, 2. Okay. 3, 0. Oopsie. 3, 0. Or negative 2, 6, negative 6, right? Just make sure you write it just like this, guys. Or negative 2, 6, negative 6. And right here, guys, we're just looking for what this kind of looks like, right? What does that look like to you? Is there any curve to that? Remember, for linear functions, we can recall that there's a constant rate of change, right? Is there any bend to this at all, right? I don't think so, right? So it doesn't seem like it's quadratic or exponential to me because there's no bend to it, right? It looks like very straight to me, very straight kind of pointed. Okay? So same thing for this one, right? 216, 323, 432. We just got to graph these into Desmos, see what it looks like, right? So x is on the left side of the comma, y is on the right side, 2 on the left, 16 on the right, 323, 3. Got to zoom out for this one probably. 432, 543. sure that's a 5. And then it was 656. Gonna have to zoom out for this one, as I suspected. Okay. Well, first off, they kind of look straight, but look at it, right? 2, 3, 4, 5, right? So 16 to 23, that's a change in 7, right? 23 minus 16, and it says a 4, 7, right? 23 to 32, 32 minus 23, that's a change in 9, right? 32, 43, that's an 11 change, right? So this is not changing at a constant rate. So I don't think it's linear here, but it doesn't look exactly quadratic because these aren't going up by squares, right? Going up a little bit slower. So it's got to be either exponential or quadratic. It doesn't look exactly quadratic, though. Okay, let's try the last one. 2, 4, 3, 8. 4 was it 16? 5, 32. His last one, 64. And look at this one, guys. So this one obviously looks like the graph isn't entirely straightened here. It seems to be going up a lot quicker, a lot faster, right? But I want you guys to notice something here. Look, 4, 8, 16, 32, 64. What's 4 times 2? 8. What's 8 times 2? 16. What's 16 times 2? 32. 32 times 2, 64. They're going up by, multiplied by 2 every time, or the power of 2, right? And what graph has the power of 2 in it? To the second power. Any power higher than 2, what graph, what parent function is that going to be? Okay, and that's the last problem, guys. So we're done with 421. And then we have a test for midterm of 422. Let's go to 423. Answer questions 1 to 5 in the following document. Should be on pages 2 to 3. And it's this effects of change document right here that it's linked in. So we go to it. And all you're doing is identifying slopes and y-intercepts. Well, that's easy enough. So I can do all of these for you guys. Y equals mx plus b. M is your slope, b is your y-intercept. So in y equals 3x plus 7, for example, right? Your m, your slope, the guy that's multiplied by x, is 3, because 3 is multiplied by x here. And 7 is your y-intercept because it's the thing that's by itself in the problem, right? How would I do these guys, right? 3x, and there's no, I don't see anything added to it, right? So what's multiplied by x here? It's the same thing that's multiplied by x in this problem too, and in this problem right here, right? There's a plus 4 and minus 5. Aren't those going to be my y-intercepts, right? So that's all you got to do, right? For this one, right? 3/5, negative 3/5. That's multiplied by x, right? Whatever's multiplied by x is my slope, right? And then I see a plus 2 on both. So aren't those my y-intercepts? But make sure we label all of these guys. I'm just making sure we understand what a slope is, what a y-intercept is in the problem. The slope is whatever is multiplied by x, right? And the y-intercept is whatever's by itself. Remember, m is your slope. If y equals 3x plus 7, the 3 is your slope. The number that is multiplied by x will always be your slope. Remember that, right? Or 3x plus 7, 7 is your y-intercept, right? The number in your equation that is by itself will always be the y-intercept of your problem. So just remember that, guys. Okay? And I do believe that is all that there is for 423, just 1 through 5, right?